Okay, now I'm going to make a trapezoid. Okay, I've got a rectangular sheet of paper here, and I'm simply going to make what I hope is a straight cut to form that into a trapezoid. Now, the task I want to give you is draw a line on this trapezoid such that if I cut along the line, I'll get two pieces that can be formed into a rectangle. So we want to take this trapezoid here, form it into a rectangle by just making one cut and reassembling the two pieces. You should pause and do that. Okay, there are at least two ways to do this with a single cut, and I think there are only two, but I haven't actually bothered to prove that, and I probably should. I'm kind of waiting. Okay, so I cut the trapezoid, I just split it right up the middle. And then all I have to do is take one of these pieces and rotate it around the point of one of the cuts. Okay, so now the pieces are like this, and I put them together, and I've got a long, skinny rectangle. Now, the picture here represents the trapezoid. B1 is this base, B2 is this base. Now, I call these bases. Why do I call these bases? Well, I haven't defined bases, but the bases of a trapezoid are the two lines that are parallel to one another. So the two sides that are parallel. A trapezoid has only two parallel sides. If it has four parallel sides, two pairs of parallel sides, then it's a parallelogram. Okay, so anyhow, here's your trapezoid, and H I label, it's an altitude. An altitude is perpendicular to one base, and it actually goes from one base to the other, and since the bases are parallel, it's perpendicular to both. So the trapezoid in this case was a right trapezoid because we had right angles down here. Now we can deal with the case of a non-right trapezoid in kind of a similar manner, and the formula that we get is going to work for any trapezoid. Okay, well, anyhow, the question then is, what are the dimensions of this rectangle? Now, before you read everything, you should figure out what the dimensions of the rectangle are. Okay, you should pause and think about that. But if you have done so, or if you haven't, I'm going to go on and explain it. So B1, when we turn the trapezoid around and put it up here, it becomes, well, here's going to be B1. It goes from here to here. And of course, B2 is just what it always was. So B1 plus B2 is going to give us the length of this rectangle. And the width of the rectangle, well, we've cut the thing in half, so that the width is going to be 1/2 the altitude. So we have 1/2 the altitude here. We have B1 and B2 here. And I've kind of cluttered up the picture, but the B1 plus B2 goes from here up to here. And now we can write down the area, which is the length times the width. The length is B1 plus B2. The width is 1/2 H. So we have B1 plus B2 multiplied by 1/2 H to give us the area being length times width. And we can then rearrange that to put the 1/2 H first. 1/2 H times B1 plus B2. The way it's probably written, in many textbooks, maybe including this one, is B1 plus B2 over 2 multiplied by H. And that's the formula for the area of a trapezoid. And that will work for any trapezoid. Now, this is a formula, but the point I'm trying to make here is there's reasoning behind the formula, and the reasoning is not that difficult. The fact that nobody coming out of our educational system, our secondary educational system, really understands or knows that argument. It's, I think, kind of an indictment, and we need to do better, and we need to push for something a little better than what we have. There's a depth behind any formula. Now, some formulas are really difficult to understand, but this is not. This is something anybody of normal intelligence can understand and can enrich their understanding of the meaning of area formulas. Okay? Now, I'll mention and challenge you to see if you can find it. There's another way that this trapezoid, right trapezoid, could be cut. Trapezoid with right angles could be cut, single cut, and reconstructed into a rectangle. And challenge you to find that.